I became involved with Keen approximately 9 years ago when Doug came to Western New England University and introduced Keen and the network to faculty. And I had this aha moment where I realized what was missing from my thermodynamics course was this integration of the technical content with social, environmental, governmental factors. So it gave the students a complete picture of kind of what they would experience in engineering and industry when they left our curriculum. Since then, I have moved to the Rochester Institute of Technology, where I'm in the mechanical engineering technology program. And I have kept some of the projects that I designed for thermodynamics, and I brought them into our thermal fluids course. So we approach thermal fluids a little differently, where we have fluid mechanics, thermodynamics, and heat transfer integrated through a series of courses together. And I really liked that approach because it prevented students from seeing like fluid mechanics, thermodynamics, and heat transfer as silo subjects, and it helps start to integrate the content together. So over the past couple of years, I've developed semester-long projects and then like just a course or a day lecture project where students will do either small group activities over the course of a day, or students will complete a semester-long project where they have different aspects of entrepreneurial mindset woven in to the project. I've woven it into homework assignments, and I can see how they start to see the world around them and they can start applying some of the technical content that we've done. And what I found what was missing after talking with students over the past couple of semesters was they feel overwhelmed with a lot of the projects that they have in our fifth year curriculum. And then they're also like taking mechanics or design, and then they have thermal fluids. And how do we integrate those courses together in terms of content? So if I'm doing a project in design, I'm going to have thermal fluids aspects, I'm going to have solid mechanics, I'm going to have materials. So I wanted to start looking at, okay, we've done integration of thermal fluids really well. Let's start to expand across the curriculum. What I plan to do with the Keen Rising Star funds is to work with faculty in the 5th year curriculum within my department to develop a project or take an existing project and have students in our 3 to 4 different courses take that one project and be able to apply the knowledge that they've learned through their time with us in the curriculum to the one project. So for example, I'm in thermal fluids. Can they take fluid mechanics principles, thermodynamic principles, and heat transfer principles and integrate it with materials, integrate it with machine design, integrate it with robotics and automation, CFD, all of the different courses that they've had. Now I want to be able to see everything come together. And then also take that mindset piece of connection and expand it out to connecting it with industry, connecting it with, society and environment, other aspects there. I really enjoy being a part of Keen and the network of faculty. I have done a lot of coaching of faculty throughout the past few years, serving as a ICE 1.0 and 2.0 coach. I really enjoy working with faculty to help them grow their mindset within Keen, and then that can transfer to the student mindset within their classrooms. I find that very enjoyable. I think Keen is a very important organization to bring to undergraduate engineering curricula and to campuses because it helps students go beyond their technical skill set that you would get from a textbook. So their textbook skills, and it helps them see the changing world around them. I think it's important for them to be able to approach complex, ambiguous problems with a different mindset than the engineering curricula was originally doing. When I introduce Keen to my students, I like to tell them that everybody is graduating from an undergraduate engineering curricula with the same knowledge. Everyone's taking heat transfer, everyone's taking material science, but what is going to make you stand out? And I tell them what my goal for them is that they're going to have a different mindset from their peers. They're going to have an entrepreneurial mindset. And what does that mean? They're going to be able to take the complex problems that they're given within industry And they're going to be able to approach it with a different mindset. They're going to be able to say, okay, I have the technical skills to solve the problem, but I also understand that there's a financial component. I understand that there's government regulations that kind of control the engineering design. There's societal factors that I have to consider. So at the end of the day, when they graduate, they are going to be a better engineer because they have this understanding that there's more than just, I have to solve the problem and I have to get the right answer. The other thing that I like to see my students kind of come with the realization at the end of their time with me is that there may not be a right answer. And I give everybody the same problem, complex, open-ended, and they all have similar solutions, but they're not the same. And so how do they pick the best one? Well, we have to think about all of these other factors. So I think that is also important for them to see, because their students today are very concerned or worried about, did I do it right? Is this the right answer? Does it match the textbook's answer? And I like that this mindset gives them the ability to kind of critically think through the problems while considering all of these other aspects that go beyond just the textbook knowledge.